So dear student, today we'll be doing the mesh analysis, okay, from a previous year paper. So let's see that. To share the page. So this is the first question. Okay. Yeah. So we have to see the power dissipated or the power released in the 2 ohm. Okay, the 2 ohm is here, right? Correct for that. So for that, I'll always assume 3 clockwise mesh current. So whenever nothing is given, always assume what clockwise mesh currents. So one here, I1, this one I'll take it as I2, and the last one I'll take it as I3. So I1, I2, and I3. Okay, so please write on parallelly, so it'll be easy for you also. Because if we're thorough with the base, then we can get full mark for this. Let me see how much marks is this? 8 mark. Okay. And if the base is strong, then we can finish off the same problem in 5 minutes also. So I1, the left bottom mesh current. And this subject you have to take it very seriously because the most backlogs come from this particular exam. Okay, so left bottom mesh current. I2, the upper mesh current. The upper. I3, obviously the right bottom. Right bottom mesh current. So the logic here is, the question is what is the power dissipated through 2 ohm circuit, right? Correct? So power, P is equal to what? VI, voltage into current, VIR. Yeah. So power is what? I square R formula, I square R. So I3 square R, I3 square R. So we have to find our I3. Okay, once I3 is found, directly we can do it. Okay, so that is the logic. If this part is enough, at least 50% of our problem is solved. Okay, 50% of the problem is solved. Okay, and one more thing is current through the clockwise, right? Yeah. Yes. So I'll just make sure that I2, I'll just mark something here. This is my I1. And if this is my I2 being passed from here, let's take I2 is passed. Then what is this thing? This will be I1 minus I2. This small thing will be what? I1 minus I2. Up to this, is it clear? Please let me know in the chat option. Up to this step, is it clear? Or any doubt is that you should ask me now only. Okay, perfect. Then fine. Okay. And here clearly the direction is also given, I0. So I0 is in the opposite direction of what? I1, right? Correct. So I0 is nothing but in the opposite direction of I1. So my I0 is equal to minus I1. Okay, and there is a dependent current source here, that is 0.5 I0. This is nothing but dependent current source. Dependent current source. And my I2 is equal to what? 0.5 I0. I2 is equal to 0.5 I0. And also my I naught is basically minus I1. So I can write I2 is equal to what? Minus 0.5 I1. Write down this thing first, and please let me know if you're clear up to this. Kindly write down everything, because I do it slowly, because once you're done with this, we can do it fast. So once you're done writing it down, please let me know in the chat option. And if there is any doubt also, please let me know. Till now. If there is no doubt, and if you written down, you can just write down done and clear. Then I'll proceed with the next. Superb. Done and clear. Okay, nice. So now the important thing. So I'm just rubbing down all of these things now. I'll just clear it out. Okay. I'll just clear everything. So it will look much more visible. Okay. So now we have to apply what? The KVL. Correct. KVL. And current is assumed to be in what? Positive thing. Correct. Yes. So if I'm writing it down, always write down here plus to minus voltage drop. Here also plus to minus voltage drop. Here also this is plus to minus, no change only. So plus to minus is what? Voltage drop. If voltage drop is there, put minus sign. Okay, this is in I1. And this is basically what? The 4 ohm. This is basically I1 minus I2. Let me just text over here. This particular part, this is I1 minus I2. Okay, this is I1 plus to minus. Everything is plus to minus only. So how do you write the equation? That also I'll write it for you, applying KVL. So plus to minus is minus 6 I1 minus 6 I1 minus 4 into I1 minus I2. Because why I am writing in this procedure, in a lot of textbook, they will put plus. Okay, minus 28 equal to 0. Equal to 0. Is this step clear? So in the next step, we can put all the minus and we can make it plus. This is plus to minus. Voltage drop means put negative sign before. This is a common practice to be used. Very basic. So again, I'm still with the basics only. Once you're done up to this, any doubt now, you can ask me. I'll make it clear. Any doubt is there, da? No doubt. Superb. Then fine. Okay. So let this equation be there as it is. Later on, I'll substitute I2 and I1 and everything. Okay. Fine. Later on, we will do those things. Okay. So the main thing is forming the equation. Forming the equation part. Now I'll go to the right mesh equation, which means through the 8 ohm, then 2 ohm and 28 volt. Okay. Now coming here also, there is one more current I told you, that is I3. I3 is passing through it. Correct. I3 is passing. Again, put what? Plus minus. plus minus, and here plus minus. Put that thing. But we know that I2 is also coming. Correct. So what is this current? So one more current is I2 is also coming here, but already I3 is there. Correct. So this 8 will be what? I3 minus I2. Splitting I3 minus I2. Because once it comes here, I2 is also there. So from I3, I have to subtract I2. Up to this, is it clear? And this is for I3. This is for I3. Remote chat option is there. Okay. Okay. So once this is over, our next step is what again to write the equations properly. Correct. So plus 2, I'll start always from the 8 to, correct. So now I'll write it down here. Text. Yeah. The next equation. Okay. The next equation, or else I'll write down here only below this. This is perfect. So 8 into, again I'm applying, and here plus to minus. So minus 8 into I3 minus I2. I3 minus, I3 minus I2. Next again, plus to minus 2I3. Minus 2I3. Okay, then again, plus to minus. Okay, but you can see the symbol of the polarity here. Plus 2, but this is plus minus here. Opposite, right? This is opposite. So minus, plus to minus is minus, but here the symbol of 28 is what? Plus minus, opposite polarity. So minus plus. So plus to minus is minus. So minus plus 28 volt is equal to 0. Is equal to 0. And then we have to find out what I2 in terms of what? I1. Correct. I2 in terms of what? I1. Okay, so I2 already I got as minus 0.5 I1 in the previous part. Let me. I2 already I got as minus 0.5 I1. That is substitute here. You will get the value of what? I1 properly. You will get the value of I1 properly. Okay. Yes. So I1, I2. And then here I3 and I2 is there. Or else you can use the calculator I1, I2 and I3. Then you can solve it. Whatever you feel like. Okay. So, Radhika, can you just try using the calculator, these two equations? And let me know what is I1, I2 and I3 values. Main thing for me is I3 value, what it is. Yeah, please try using the calculator and let me know what is the value. Please let me know what is the I3 value. Okay. Yeah. Okay. I2. Okay. I3. Are you using the calculator or without the calculator? With the equations. Go to mode equation 5. That only you're doing it, right? Okay. Without calculator. Okay. Fine. Yeah. I2. Okay. What about my I3 value? That is only important for me. Yeah. I3 it is 2.45. Let me see. Second. Sorry, I have unmuted myself. Okay. Yeah, the mic is muted. Thank you. Thank you, Dharnika, for that. So coming to the, I think, yeah, we will find the I1 value, check out all the things, substitute wherever. So take this as a reference page. Okay. And this is from a student's note. Okay. And I1. And also we know that I2 is equal to what? Minus 0.5 I1. So that also you have to put. So half of this. Minus minus plus. Then substitute in the third equation. Okay. Then solve it and you get I3. And once you get I3, correct power through the 2 ohm resistor. So I3 square R. R is nothing but 2 ohm. 2 ohm resistor. So 3.733 square into 2. 3.733 square into 2. You will get around 27.88 watts. So that's it about this particular question. Okay, so thank you.